All right, in 11.189 by request, we're told that if we can assume that the limit as n goes to infinity of a sub n is equal to 0, and we know that our sequence is that a different sequence is bounded, then the limit as n goes to infinity of the product of those two sequences must be 0. We want to prove that. So I'm going to go ahead and make the assumption. I'll go ahead and actually just grab that and copy it just because I'm too lazy to write it. So copy, and I'll go over here and paste it. Boop. So we're going to assume the following is true. I know I probably could have written that faster than copying and pasting it. Assume that those two things are true, period. Okay. Now, what I'm going to go ahead and do is I want to showcase the product of those two functions tends to 0. The way I'm going to do that is because they told me that b sub n is bounded, we can assume that b sub n is between two numbers, always between a capital M and a lowercase m. And now what I'm going to do is multiply all three sides because I want to get the product of an and bn. So what I'm going to do is multiply all three sides by a sub n. Now when I do this, I'm going to be assuming that a sub n is positive, but it actually will not matter. So I'm going to say, without loss of generality, and I'll tell you why in a moment. Let me just finish writing that. Assume that a sub n is positive. If you do that, that will imply that when you multiply all three sides, a sub n times m should be less than or equal to a sub n times b sub n should be less than or equal to a sub n times capital M. The main reason why I don't really care if a sub n is negative is because I'm just trying to find a bound, a upper and lower bound for a sub n times b sub n. If a sub n is negative, then who cares? Those inequalities will just switch, but it's still bounded. If a sub n is equal to 0, better, actually, because those two outer edges are going to be 0. So I'm just trying to bound it. And I don't care if a sub n is positive or negative. Now I'm going to, the reason why is this, because I'm going to take the limit. The limit as n goes to infinity of the left-hand side is going to be the constant times the limit as n goes to infinity of a sub n, and we are assuming that that is 0. So that's m times 0, which is 0. Likewise, the right-hand side, limit as n goes to infinity of a sub n times capital M, we can factor out that capital M, and again, that limit is 0. So the right-hand side tends to 0. And by the squeeze theorem, that just tells us the limit as n goes to infinity of the product must be 0. And again, that's by squeeze theorem. That's it.